Now differentiate tangent 3x with respect to x by first principle. Solution: let y is equal to tan 3x. Apply the same process of first principle or the 4-step process on tan 3x. So that is, first step is y plus delta y, and on right hand side that will become tan 3x plus delta x. This x just replace to x plus delta x, and delta y will become tan 3x plus 3 delta x by multiplying this 3 to x and delta x and this minus y. And we know that the value of y is tan 3x, so just put the value of y is equal to tan 3x here, and this will become delta y is equal to tan 3x plus 3 delta x minus tan 3x. Now we are here to simplify this step. So tan 3x plus 3 delta x can be written as sine over cos. This angle will be as it is. So we have sine 3x plus 3 delta x divided by cos 3x plus 3 delta x minus this tan 3x will become sine 3x divided by cos 3x. Obviously that will simplify by taking LCM. So we apply LCM here. This cos 3x plus 3 delta x into cos 3x will be LCM. So simplifying this thing, that will become sine 3x plus 3 delta x into cos 3x minus this cos 3x will be cancelled out, and this cos will multiply to this sine, and this will of the form like this. And now we have actually sine alpha cos beta minus cos alpha and sine beta, which is actually the formula like this one, sine alpha minus beta, which can be written as sine alpha cos beta minus cos alpha sine beta. So this is actually open form of this formula. We have this one, and we can merge it to like this, sine alpha minus beta. So by applying this formula, that is actually sine alpha minus beta, and alpha is here 3x plus 3 delta x and beta is 3x. So by using this result, we can write sine alpha, which is 3x plus 3 delta x, minus beta, which is this 3x, and this denominator will be as it is, cos 3x plus 3 delta x into cos 3x. This 3x will be cancelled out, and we have sine 3 delta x divided by cos 3x plus 3 delta x into cos of 3x. So we just complete our simplification step here. Now the step is dividing by delta x both sides. So dividing by delta x on both sides, that will become delta y by delta x, and on right hand side that is actually 3 cos 3x plus 3 delta x cos 3x into sine 3 delta x divided by 3 delta x. So as this one is sine 3 delta x, we have to divide delta x on both sides. So this is actually just to complete the result as we discussed in our previous question, that we have actually the formula sine x divided by x limit x approaches to 0, that is equal to 1. So just to complete this result, we have angle here sine 3 delta x, but when we divide delta x, so along this we have to take 3 to complete this result, as there should be in denominator the same thing which is appearing as an angle with sine. So here we have sine 3 delta x, and when we divide delta x, we must have 3 with this delta x. So we just multiplying and dividing this 3. So that will become next step is taking limit delta x approaches to 0. We have limit delta x approaches to 0, delta y by delta x, and on right hand side that will become delta x approaches to 0, 3 over this one, and sine 3 delta x over 3 delta x. This delta x is actually dividing step, and this 3 and 3 is actually multiplying and divide to complete this formula. So limit will apply separately on both of these two parts. On left hand side that will become dy by dx, and on right hand side this 3 is the constant term, so will be unaffected and will remain same, and this delta x will become 0. We have cos 3x. Here there is no delta x, so will remain cos 3x, and by applying limit delta x approaches to 0 on this part will become 1 by using this result, which is 1. So that will become 3 cos, and this cos will become cos square 3x. So d by dx, and this y was actually tan 3x, so derivative of tan 3x will become 3, and this 1 over cos square can be written as secant square 3x. So again we can verify our result that actually the original formula of d by dx, or derivative of tan x, is equal to secant square x. But when we differentiate, by definition, d by dx of tan 3x, when we differentiate this tan 3x, that is first appearing derivative of tan, which is actually secant square 3x, and then derivative will apply on this angle, and the derivative of 3x will become 3, which is multiplying by this like this. So 3 into secant square 3x will be the derivative of tan 3x. So again we may conclude that derivative will apply first on this trigonometric functions, and then derivative will apply on this angle. So this will become derivative of tan is secant square, and derivative of 3x will be 3. So we have here 3 secant square 3x is the derivative of tan 3x.